day, every day, germs and our immune cells are interacting in the body. Our immune system is extremely complex, with many different ways of dealing with germs. The immune system has two major branches. The first is called the innate immune response. It is the first response after germs enter the body. Immune cells that participate in the innate immune response include macrophages and neutrophils. Both of these immune cells find germs, grab onto them, and break them into harmless pieces. The second response is called the adaptive immune response. Adaptive immunity occurs after the germ has come into the body and gotten past the innate immune response. This response focuses on removing or degrading the germ, as well as remembering certain germs so that they are recognized at the next appearance in the body. Immune cells that participate in the adaptive immune response are T helper cells, cytotoxic T cells, memory T cells, memory B cells, and plasma cells. You can think of innate immunity as a gardener seeing a weed seed blowing into the garden and taking it out of the garden. Adaptive immunity would be the gardener seeing a weed growing in the garden again and removing it promptly before it causes any damage to the plants. Each immune system response cannot work without the other. All of the immune cells work together to keep the body in balance. These gardeners are necessary because even though a garden is surrounded by barriers, like marigolds, trenches, or fences, to discourage most pests, some germs still get in. Like a garden, our body isn't pest-proof. Germs, which can be viruses, bacteria, or fungi, can enter the body through mucous membranes, cuts in the skin, breathing, or ingestion. Once germs have entered the body, they grow and produce materials that may disrupt the body's natural balance. Not all germs cause a major disruption of the body's balance, just like not all weeds and pests ruin a garden's natural balance of nutrient availability, access to sunlight, and space for the rest of the plants. But when pests do get into the gardeners are there to keep their garden as healthy as possible, making sure that pests don't take valuable space or destroy plants. Gardeners are constantly needed to keep the pests at a low level. Gardeners gain knowledge about pests from experience, which is how the immune cells know which germs to get rid of. T cells originate in the bone marrow, then travel to the thymus where they mature. T cells develop in the thymus to be able to recognize germs. After the thymus, they are released into the bloodstream to encounter germs. Macrophages and B cells grab onto germs and degrade them, keeping a portion of the germ to use to recognize the same kind of germ later on. This portion of the germ is like a barcode or a label that the macrophage or B cell can show T cells so they can identify those germs upon second appearance as well. Once a germ is caught by either a macrophage or a B cell, the barcode is presented to either a cytotoxic T cell or a helper T cell. When a cytotoxic T cell encounters a germ with the same barcode as was presented earlier, it injects the germ with toxins. The toxin acts like an herbicide, preventing the weed from growing. When a helper T cell is presented with a barcode, it reacts by stimulating the macrophages and B cells to work more efficiently. Macrophages engulf germs faster, and B cells are stimulated to produce memory B cells and plasma cells, which secrete antibodies. In a garden, this would be like one gardener providing food and water to other gardeners, so they are able to continue weeding and learning about specific pests and how to get rid of them. This process is like a gardener aiding the growth and development of plants by providing special nutrients like Miracle-Gro. Mature B cells are released into the bloodstream and are able to recognize germs that get into the body. When B cells find germs, they become plasma cells. The plasma cell makes an antibody, which then moves into the bloodstream and finds germs with a specific barcode on it, marking it for macrophages to identify. When an antibody marks a germ, macrophages are able to recognize these germs better. Similar to this process would be a highly knowledgeable gardener marking weeds for an inexperienced gardener to pull.